Okay, today we are going to talk about factoring and reviewing all the types of factoring that you should have done in Algebra 1. We will learn some more about factoring, but again, this is a review of stuff you've done from Algebra 1, so if this is not enough for you or you want to talk about it more, please come see me. Okay, this first part that we have actually, excuse me, actually deals with quadratic um, most of what we're dealing with is quadratic, but the first section deals with those that are higher than quadratic also. Because the very first thing that you ever want to do when you're factoring is remember to find the GCF. So your first step always is to go find the greatest common factor in your expressions, no matter how many you have. So if I look at this first one, and when you're looking for that GCF, y'all, remember that the GCF can be with numbers and with variables, so you're not limited to either one. So when you're looking for this, and I look at the numbers, 4 and 8, okay, the GCF of 4 and 8, or the largest number that goes into both of those, is 4, okay? Then I look at my variables, and when I look at the variables, if there's a variable in all the terms, then you want your common factor will be the one with the lowest exponent. So there's an x in both, and there's a y in both, and the lower exponent of y is 1, so it's just 4xy. And then you can think about dividing these two things, or I like to think of it as I multiply what do I multiply this by to get to that. I took out the x, I took out the y, but the 4 I would need times 2 to get it in there. Whatever plus or minus you have in your problem will also be inside the parentheses. Okay, 4 divided by 4 is 1. I took out an x, but I have an extra y. So, and the nice thing about factoring is all these problems you can check. Okay, 4 times 2 is 8xy, and then 4 times 4xy times y is going to be our 4xy squared. Okay, another example, let's go look at number 4. Okay, again, I'm looking at the numbers first, and there's a common factor of 5, and then they both have an A, they both have a B, they both have a C, they do not both have a D. Now, what is the lower exponent of A? It's A to the first. B, I have B to the third and B squared, so I'm going to have B squared. And C, I have C to the fourth and C squared, so it's going to be C squared. And then I'm working backwards. 5 times what is 20? So I have a 4. A and A, those are the same. I have took out 2 of them, but I had 3 to begin with, so that means there's 1 not accounted for. I have 2 that I took out. I started with 4, so that means I have 2 left inside. I did not take out a D, so that D stays there. And if you look at this, 5ab squared c squared, that's exactly what I took out, which is one of the things I want to point out to you. If you start with 2 terms when you're pulling out a greatest common factor, you have to have 2 terms on the inside. So every time you have a plus or minus in the original problem, you're going to have a plus or minus here. And if these two look exactly the same, then hopefully you realize that that should be a 1. And again, you can multiply it back out and realize that that times 1 is going to give you what you have. Okay? All right. Oh, now I was just say one more. We'll do 2 more. Okay, so look at number 6. So I'm looking at 6, and generally we take out a negative if that leading term is negative, so I will take out that negative. Just so, again, you're familiar. The largest number that goes into 16, 24, and 32 is 8. Then I look at my variables. They all have a p in them. That's p to the third, p squared, p to the fourth. So I'm going to take the smallest of those. Then I have q squared, q to the third, and q. Again, the smallest exponent is q to the first. And so then I'm going to work backwards. Negative 8 times what is negative 16? That's 2. P, I have 2 p's here, but I need 3, so I need another p. I have 1 here and 2 up here, so I need another one. Always, if I got a plus, it's going to, oh, actually, I took out a negative, y'all. So that becomes minus because you switched the signs. Negative 8 times what is 24? Well, negative 8 times negative 3, so you can see why those signs changed. P squared's the same, so I don't write it again. Q, I have 1 here, and I have 3 here, which is, so I need 2 more to make that 3, because Q times Q squared will give me Q cubed. Negative 8 times what is negative 32, and that's a positive 4. I took out 2 p's, but I started with 4, so I have 2 left. And I have 1 q here and 1 q there, so I'm not going to write another one. And that's what that is. Again, you could multiply it back out if you want to check your work, but good review. One of the things, though, also, two terms tend to stump people a lot because we're going to get into another type of problem in just a minute. But when you look at these two terms, they don't have a number in common, but they do have a variable in common. And that variable is x. And when I take out the x, I have an 8 left in the first term. That doesn't change. And then I have an x on that last term. And like I said, sometimes the easiest ones are the ones that we mess up. Multiply it back out. X times 8 is 8x. X times x is x squared. Okay, so our next group of problems are those that we're going to classify as the difference of two squares. So what's most important about that is what are squares, because if you don't know your squared numbers, you're going to have a little difficulty recognizing when you have the difference of two squares. Okay, with numbers, okay, let's start here. The squares that are numbers, we of course have 1 times 1, which is 1 squared. 2 squared is 4. 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 8, 9. 10 squared. 11 squared. 12 squared. 13 squared. Oops, I left off. Don't erase them all. I thought that would do that. 144. 13 squared. 14 squared. 15 squared. That's pretty high. High enough. Now, you need to understand where they came from. You have a calculator on your test. You can list them out. You don't have to memorize it, but you need to write them down often so that they will become familiar to you. So the other one that is a perfect square, how do we know if a variable is a perfect square? Well, you know that a variable is a perfect square if the exponent is an even number, because you're just going to cut it in half. If the exponent is even, then we know that we have a perfect square. So let's go see what's going to happen. The difference of two squares. So I said if one term is squared and the second term is squared and there's a difference between them, that's your minus, then they always factor to A and B. They look exactly the same. You're taking the square root of each term, except for one is plus and one is minus. Does it matter which one you put first? Absolutely not. Okay, so let's go look at some examples of this. Again, remember the first thing we did was GCF, so you should always still look and see, do they have anything in common? And they don't, but this is a perfect square, and that's a perfect square. They're in our list. So I'm going to take, I'm going to write it over here, the square root of the first term and the square root of the last term. And I write them so they look exactly the same, and one is minus and one is plus. And again, the order does not matter that you write that in. Okay? Look at number 2. Okay? That's a perfect square. That's a perfect square. There's nothing in common with those two. The square root of 4 is 2. N squared is n, so I have 2n 7, 2n and 7. One is a plus and one is a minus. So I hope you're beginning to see that if you recognize this pattern, then it makes your life easier. Look at down below, okay, p squared. It's an even exponent, so that's p square root of 36. So we have p minus 6, and then p plus 6. So when you're looking at two terms, okay, as I said just a minute ago, the first thing you're always supposed to do is look for a GCF. So this one here, you need to find that GCF, which in this case is 2. And when you take out a 2, you're left with x squared minus 9. Okay? 2 times 9 is 18. So again, right here, and this happens often, I have the difference of two squares. This is a perfect square, and that's a perfect square. So I would go one step further. The square root of x squared is x, and the square root of 9 is 3. So this looks like this. So there you go, and that's our second group. Okay, our third group is something called PSTs, and PSTs look like, we'd actually talked about this a little bit in class on previously, and it's a squared plus 2ab plus b squared. Okay, this is a perfect square, and this is a perfect square, so I'm going to go, oh, that's a and b squared. And whatever this sign is what I'm going to have right here. Now, you should always check it, because if you go do that square root thing, then multiply these two together, a times b, and then times 2, and that'll be your middle term. And I'll talk about it as we go through. Okay? Now, the only thing that's going to be different about this is sometimes there'll be a minus sign there, and if there's a minus sign there, then there's a minus sign in your answer. Okay? So, um, let's go do that. And one thing I did want to mention, let me go back here real quick before we go on. Okay? I don't know if y'all have ever been told this, but it's a good time to introduce it to your vocabulary. When you have two factors that are exactly the same, except for the sign in between them is different, then these two factors are called conjugates of each other. We will be using that a lot as we go through this year, so I want you to be familiar with that. Okay, so back to our PSTs, a squared plus 2ab plus b squared. So I'm looking at a term, and I say, ooh, that's a perfect square. Ooh, that's a perfect square. So since it's a perfect square, I'm going to write it down and go square root of that. It always takes that middle sign and the square root of that. And then I'm going to square it. And when I check it, I'm going to multiply these two. 1 times 3x is 3x, and 3x times 2 is 6x. So I know that I have factored that correctly. Okay, and when we learn the other method in review, you're going to realize if you just recognize these, your life's going to be a lot easier. Okay, 9 is a perfect square. 4 is a perfect square. So square root of 9, square root of 4. When I multiply 3 times 2, I get 6 times 2 is 12, which is my middle term. So I know that that checks out. Okay, let's look at number 10. Big numbers, but not so bad, because 16 is a perfect square and 25 is a perfect square. But notice this one they both have variables on them. Not a problem. Square root of 16 is 4. X squared is x. Square root of 25 is 5. Y squared is 5. It always takes the sign of the second term. So when I multiply those together, 4 times 5 is 20xy times 2 is 40xy, and that's my middle term. Okay, two more. Let's go to, that's just like that one. Let's go just do one more. 18. Look at 18 because it's got a minus sign. We had one with a minus sign. Again, looks exactly the same as that one we just did. So it will be the same, which will be 4x minus 5y quantity squared. Okay, so go through and practice that pattern. And now, did I tell y'all what PST stood for? That probably would have been nice. PST stands for a perfect square trinomial. Okay, trinomial because it has three terms, and perfect squares because those first and last terms are perfect squares. Okay, but obviously it's a lot easier to say PST than a perfect square trinomial every time. Okay, grouping. So when we do our grouping, we're going to, generally we have four terms when we're doing the grouping, and you're going to group it into two pairs. And then in each pair, you're going to find the GCF. That's the basic concept, and that's actually how I'm going to do the next group. But watch what happens. So I have two pairs, and generally it's going to be two and two. Okay? Um, so I look at those two, I group in those together, and I always have to know that sign. So when I group my pairs, I'm looking for the GCF in just these two. So the GCF here is 3a squared, and what's left is 3 times 4 gives me 12, and then I have 2 here, and I end up with 3, so I need another one. And then I have a minus sign, and then 3a squared times what is 9a squared, and that's a 3. I always take that sign, and then look at 4a and 3, and you go, well, they don't have anything in common. So that's when you write the number 1, and then you copy it down, okay, because they didn't have anything in common. Now, if when you get to this step, these two terms do not look exactly the same, then you have done the wrong thing, okay? So, first and foremost, you can't go any further and look at your factoring because you might have just messed up. But if you notice now, that's what is in common to both of these terms. So I'm going to take out 4a minus 3, and what do I have left over here is 3a squared, and then plus 1. And now I have factored those four terms into two factors. Okay, let's try the next one. Again, I have four terms, so I'm grouping them into two pairs, two groups of two. Always need that sign. Okay, so I look at these two, and what do they have in common? 2 and 5 have nothing in common, but they both have a p. So I'm going to start off with p squared, and that leaves me with 2p, because I had 2 here, and I have to get to 3, so I needed 1 there, plus 5. P squared is the same, so I don't have anything else there. Always write down that sign that we circled. 6p and 15, what do they have in common? They have a common factor of 3. And what am I left with? Now, I'm going to tell y'all, you can go factor it out yourself, but if it's not the same as this, it doesn't do you any good. So I'm going to go ahead and write down 2p plus 5. But then I'm going to check it. 3 times 2p is 6p, and 3 times 5 is 15. So once again, I have the same thing in both sets of parentheses, and this is my common factor. So I'm going to take that out. I'm going to have 2p plus 5, and what I have left is p squared plus 3. And now we've done it. Okay, we're going to do quite a bit more of that, but right now I want to do one more example so you know how to handle it if it is a negative. Okay, so look at number 8. Okay, again, oh, some nice doozy numbers there. And you know what? We didn't have it earlier, but in this one, it might be better if we make sure to always look for that GCF first. So, I'm going to take a wild guess. And because I know that 7 goes into all of these, I'm going to see if 7 goes into that one. And it does. It goes in 32 times. Do I have any other variables in common? I don't. Those have an A, but there's not any other variables. So I'm going to take out a 7, and that leaves me with 32AZ plus 56 divided by 7 is 8AC minus 84 divided by 7 is 12YZ minus 3YC. It looks harder than it is, y'all. Okay, so now I'm ready to do my grouping. So I'm going to group the first two and the last two, and I circle the sign in the middle because that's what I'm going to put in between them. Okay, you got to carry down that 7. And if you might, because of what we're fixing to do, you might put brackets here. What do these two have in common? 8 looks like 8a because 8 goes into both of those and they both have an a. And what am I left with is 32 divided by 8 is 4z plus, take out an 8a, I think I have a c left. Now I'm going to carry down the minus. I'm going to find what they have in common, which is, looks like 3y. And remember, I'm going to kind of cheat and write that down again. So that's 4z plus c. And then I'm going to check it. 3y, negative 3y times 4z is negative 12yc. And negative 3y times c is negative 3yc. So I've got the same factor here. Okay? If you don't have a highlighter, just squiggle underneath it. It kind of helps it easier, makes it easier to take it out. So I have my 7, and then I'm taking out 4z plus c, because that was what both of them had in common. And what do I have left is 8a minus 3y. And there we have it. Okay? So that is our factor by grouping. Now we're going to go into factoring trinomials. Okay? Trinomials, I hope everybody knows. A trinomial is, of course, one with three terms. And they look like ax squared plus bx plus c. Okay? That's just our standard trinomial form. So you have to be able to identify a and b and c in each problem. Then you're going to multiply a times c, and we're going to write a number there, and I'm going to do some so you'll see. And then you're going to figure out what b is and write that number there. Then hopefully you will see according to this chart, and it'll be easy when I do some problems. I'm looking for two numbers that multiply together to give me AC, but add together to give me B. Okay, so let's go do some examples like that. But somebody walked in, so give me 1 second. Now, oftentimes on this chart right here is most helpful when we get into the next page. The difference between this page and the next page that looks like that, I don't know if y'all can tell from the first four problems, okay? On this page, all of our values of A are equal to 1. And so it makes factoring a lot easier, as you see, okay? Um, so what we're going to do is actually just concentrating on this one, getting through with how do you actually get those factors. So one thing that I want to tell you is this sign right here can help you check and make sure that you get things right. But this number could either be plus, obviously it could be a plus, or it could be a minus, okay? If it is a plus, then you are looking for a sum of your factors, and they have to be the same sign, okay? If it is a minus, then you're looking for the difference of those factors, and your signs will be different, okay? So keep that in mind. So if I'm looking for a plus, then I know that my signs will be the same when I finally end up, okay? So these particular ones, we know that A is equal to 1, B is equal to 8, and C is equal to 7. So A times C is, of course, 7, and B is equal to 8. Now, 1 times 7, that doesn't look like an old Pooh Bear. B equals 8. Okay, so 1 times 7, because remember A times C, we're looking for times, and 1 plus 7. 1 times 7 gives us 7. 1 plus 8 does not give us 7. Sorry, trying to do too much in my head there. 1 plus 7 gives us 8. And so, one of the ways that this will help you is to break this one up into 1 and 7. So this becomes b squared plus 1b plus 7b plus 7. And then do what we did before. Okay? So we looked at this. The common factor between these two is b, which leaves me with b plus 1. Then I bring down my plus sign. and I have 7 and b plus 1. And then what's the common factor between these two? B plus 1. And then what's left is b plus 7. Now, some of y'all are thinking, oh my goodness, this is so easy. Why is she going through all these steps? Okay, I'm doing it because some people it's not easy. If you can get on these easier problems from here to here without this, that's fine. I'm just showing you how those people who might not have done so well in Algebra 1 can get it. Okay, so um, my last number here, C, was a positive number, so I was looking for a sum, and my signs were the same. Really what I want to get out is I have the same sign, and I don't know why I have an E on the word sign there. Okay, they have the same sign, so at the end my signs are the same. Look at this one. Okay, A is 1 again, B is negative 11, and C is positive 10. So again, my signs will be the same at the end. Okay, A times C, 10 times 1, and then B is negative 11. So what two numbers? Well, of course it's 1 times 10, but this time if you notice it's got to be negative 1 plus negative 10, or minus 1 and minus 10. So these two are both negative also. So when you break this up, n squared minus 1n minus 10n plus 10. So I'm only breaking up the 11n, and then again grouping common factor of n, leaving me with n minus 1. Carry down my minus sign. Common factor of 10, and remember I said keep that factor the same. So that's minus 10 and plus 10, giving me here, and then here is my common factor, n minus 1, and then what's left is n minus 10. And so that's what I have. But this is where I was saying this is a plus sign. My signs are the same, okay? And they're both whatever that is in the middle. Okay? Look at this next one. Okay? We have A is 1, B is 1, and C is negative 90. So A times C is negative 90, and B is equal to 1. So you have to, this is kind of the hardest part, you got to think of two numbers that multiply and give me negative 90 and add to give me 1. So again, some people are faster at this than others, but 10 and negative 9 fit the bill. So when I break it up, I'm going to write m squared plus, I'm breaking, this is how I'm breaking, this b is allowing me to break up that middle term, okay? B squared plus 10m minus 9m minus 90. Again, I'm grouping in 2 by 2, okay? And that gives me m times m plus 10 minus, always use that sign, they have a common factor of 9, and I'm going to write it down, and I'm not sure, so I'm going to check it. Minus 9 times m is minus 9m, minus 9 times 10 is minus 90. And here is that common factor that I'm going to bring out. So that's m plus 10 times m minus n. Okay? Again, some of y'all can get to that easily because you've had practice with it. Okay? Um, so I think that's enough practice of those because I really want to get into the harder ones, which are on the next page. And on this page, this is where A does not equal 1. Okay? So these are the ones that tend to be the hardest problems to factor. Okay? So if you practice that problem we just did in the previous group, then it will make this part easier. Okay, hold on one second. Okay, that was pretty short, visitor. All right, so A is not equal to 1 on these. And again, every time you do these problems, you always want to look for that GCF, which we don't have one here. So A is equal to 3, B is equal to -2, and C is equal to -5. So A times C is 3 times -5, which is -15. And B is equal to -2. Okay, so I'm looking for two numbers that multiply to give me 15 and add, combine. Basically, if you've got a negative here, then you're going to have signs that are different signs. So whether you want to think of subtracting or adding two different ones is up to you. Okay, um, but hopefully you all see that -5 and 3 actually fit that bill. So -5, 3, and -5 plus 3 give me -2. So when I break this up, I'm going to have 3p squared. It doesn't matter which way, we'll all end up on the same place. So you can put minus 5p plus 3p minus 5. So I'm taking these two as my coefficients, -5 and 3. And then I'm doing the same thing, okay? And breaking it up. 3p squared minus 5p. The common factor is p, leaving me with 3p minus 5. Always carry down that sign. And these don't have anything in common. So what am I going to write? Hopefully you said 1. So that leaves me with 3p minus 5, which again we said had to be that first one. So that gives me my common factor is what's in my parentheses. So I'm going to write 3p minus 5 times p plus 1. So you're going to have a quiz on all these different types of factoring. So keep in mind that you can check this quiz before you turn it in, because you multiply the first two terms. You go FOIL, just like you've done before. 3p times p is 3p squared. -5 times 1 is -5. And your middle term is -5p plus 3p. And that gives me minus 2p. Okay, so let's go do number 2. Now, purposely, it may be annoying, but I tried to put each of these groups in a different color so that you could go, oh, that's a red group problem, or that's a blue group problem, or something as you're working through when you get them mixed up. Okay, so A is 2, B is 3, and C is -9. So AC is -18. Looking for two numbers that multiply that. And B is equal to 3. And I'm looking for two numbers that add to give me that. So first thing I'm going to try is -9 and 2, and that of course does not give me 3. But this is kind of where I get into you subtract the numbers to get to that 3. So we're looking for the factors of 18 that have a difference of 3. And again, this may be the longest part of the process for some people, but 6 and 3 give me 18, 6 times 3, and I subtract to give me 3. And if I want a positive 3, then I need the 6 to be positive and the 3 to be negative. So that tells me I'm going to break that up into 6n plus 6n minus 3n. And then I carry down the rest of the problem, and then I group into pairs. So the greatest common factor with these two is 2n, leaving me with n plus 3. Always carry down that sign. Common factor between these two is a 3, and I'm going to copy that factor. And when I copy that factor, I'm going to check it. Minus 3 times n is minus 3n. Minus 3 times 3 is -9. So I did factor that correctly. And I take out my common factor of n plus 3, and I'm left with 2n minus 3. Okay, so same process every single time, and you have lots to practice before our quiz. And if you need another worksheet of them all mixed up, I will put one of those on the calendar. So please come see me, work within your groups, and get that done. But come see me if you have any questions that you can't get answered.